In this video lecture, we're going to discuss one of the example of greedy algorithm, which is selection sort. So how does it work? So let's suppose we have this array. It contains 11, 25, 12, 22, and 64. And we're going to sort it from the smallest to the biggest value. So when we implement this sorting algorithm, we need to have these three columns: sorted sublist, unsorted sublist, and the list element in unsorted list. So initially, there's no value in the sorted sublist because we haven't do anything yet with the elements of the array, and definitely all the values in the array are included in the unsorted sublist. So now let's implement the sorting algorithm. So first, we get the first value, and then compare it with the second value, and then retain the smallest value. So compare 11, 25. 11 is the smallest value. So compare it again with the next value, which is 12. 11 is still the smallest. So compare 11 with 22. 11 is still the smallest. And then compare with this last value, which is 64. Therefore, 11 is the least value among the 5 elements of the array. So therefore, this 11 will be the first element in the sorted sublist, and the elements in an unsorted sublist will be 25, 12, 22, and 64. Same process, we're going to compare the first value with the next value. 25 compare with 12. 12 is the smallest, so therefore 12 will be compared with the other values. So 12 compared with 22, 12 is the smallest, so 12 compared with 64, 12 is the smallest. So among the four, 12 is the smallest, therefore 12 be included in the sorted sublist after the 11. So now in the unsorted sublist, we only have three elements, which are 25, 22, and 64. So compare the first element to the second element. 22 is the smallest, so therefore 22 will be conferred on the third element, and we know that 22 is the smallest. Therefore, the third element in the sorted sublist will be 22. So now we have two two values in the unsorted sublist, which are 25 and 64. So compare with 25 with 64. 25 is the smallest. So therefore, the fourth element in the sorted sublist will be 25, and the unsorted sublist will be 64. Only 64 is left in the unsorted sublist. So we cannot compare it to any value. Therefore, automatically, 64 will be the last term in the sorted sublist. So therefore, the order will be 11, 12, 22, 25, 64. So this is the result of the sorted algorithm, sorting algorithm rather. So what is the big O, big omega, and big theta of this algorithm? So for the big omega, it's n squared. Big theta is also n squared, and the big O is n squared. So how do we come up with the big O n squared? So basically, the comparison is based on n squared, while the swap, we all know that it's one time for each cycle. It's just n, well, just one. So total of it will be n. Okay. So which among these two O will be the higher value? Definitely, it's n squared. So this will be the big O notation for the whole algorithm. So how did we come up with the n squared of the comparison? So considering the cycle, okay, so on the first cycle, the comparison is n minus 1. Second cycle, n minus 2. And on the last cycle, it will just be 1. So if we're going to simplify this, the equation is n times n minus 1 divided by 2. Simplifying the numerator, we have n squared minus n. So removing the uh, the whole number or the integer, we only have n squared minus n. So which is bigger, n squared or n? It's n squared. So therefore, n squared will be the big O notation. So that's how we determine the big O. Okay, so that's it for this video lecture. More example, more greedy algorithm discussion on the next video lecture. Thank you for listening.